Let us now talk about if-else statement. That is dual alternative. If condition is true, execute these statements. Else, execute other statements. Now, in general, else only makes sense with if. It comes with no its own condition. Basically, the purpose of else is sketched all other cases when this condition is not true somehow. Let us illustrate it in this example. So if sales is greater than 50,000, the bonus is 500. Else, we know that in this particular case, else means that sales are less or equal to 50,000. But in general, else does not need to worry about that. So else is there to catch all other cases. In this specific scenario, when sales are not greater than 50,000. So print, you did not get a bonus. Enter your sales, 50,000. 50,000. You did not get a bonus because 50,000 is not greater than 50,000. So this condition was not true. It actually returned false, and hence this code was not executed. Bonus was not reassigned to be 500. All right. Hopefully that makes sense. And now let's go back to our temperature program. And here is our threshold, temperature less than 40. In case that is true, we will print a little cold. Otherwise, we will print nice weather. So let me open that program again. And I will say version 3. So if temperature is less than, let's check with the original flowchart, less than 40, wear cold. Else, print nice weather. We are okay. Let me not modify the other statement. I'll delete this and run, make sure it works as intended. My temperature is 45. Well, not nice weather. And rerun. For the temperature 30, wear cold. All right. So that works. And in general, you should understand that temperature is a variable. It is supplied during the program execution. I, as a programmer, don't need to know what the user has in mind. I'm just creating a logical structure that will allow the program to decide for each user the temperature can be different, and what they enter will be different because maybe a different user will run it, or maybe I will run it at different times. So we ask the user to provide the temperature. If temperature less than 40, if this highlighted statement is true, then wear cold. Else, nice weather, wear hat. All right. I don't want to go into comparing strings right now, so I'm going to play with nested decision structure. Given this a little flowchart, I want to reverse engineer a problem. So like come up with a story. And if you like, you can go to the book, and around the figure 312 in chapter 3, there will be a story. But basically, think what the story is. Now the story is the following. If salary is greater than 30,000, if that's true, we also check years on job greater or equal to 2. If that is true, you qualify for a loan. So in order to qualify for a loan, you need salary greater or equal to 30,000 and also at least 2 years on the job. In every other case, you don't get a loan, and there is some explanation for it. So this is what we are doing. Feel free to pause the video and do it yourself. So new file, that will be a program for a decision maker for giving a loan. Now, the online decision makers for the bank are about the same, only much more sophisticated. And actually, AI is involved, which does not rigidly follow one set of questions. Now, where does this variable come from? Look at the flowchart and spot the variables. There is a variable salary and years on job. So salary should be a numeric value. I'm going to ask the user for the value, of course, but also I need to convert it. So my nested function call, float is the author function. It works after input, float input. And actually, same story goes for years on job. Maybe you can make some better decisions right now, and we'll talk about it later. Enter your salary. I need to finish this prompt, and here, years on the job. How long on the job? So we have to have these variables in order to implement this logic. So salary is a variable, the values, and years on job is a variable. Now, values have to come from somewhere. All right. Now, the first if statement if salary is greater or equal to 30,000, then do the true part. If that is true, we have another condition. That is the nested if statement. So another if statement, if years on job greater or equal to 2, notice colon, press enter, automatically indents. If you have a column anywhere in Python, then press enter, it automatically provides proper indentation. And what we should print in this case is you qualify for a loan. Print you qualify for the loan. And then there should be another option that is else. For this statement, there should be an else. Else, print you need to be at least 2 years to be on your current job. Job for at least 2 years. Let me make it full screen for a little bit. So we are done with the inside if-else statement. Now, if-else statement, the statement that I just highlighted, corresponds to this part of the diagram, the inner diamond and the corresponding printing statement. And now we have an else statement for the outside if-else statement. We have the if part And now we need an else part, else, print, you must earn at least 30,000 per year to qualify. All right, so those are, this actually realizes this nested decision structure. Before I run it, I want to emphasize something. The highlighted part is a single if-else statement. All this is one if-else statement, one programming statement. Else will not make sense without the preceding if. Inside this if-else statement, in the if case, there is another if-else statement. So that's why it is called a nested if-else statement. Let's run it, make sure it works. That is my loan program. Enter your salary. Let me make this smaller so that you can still see the code. Salary 32,000. How long on the job? 4 years. You'll qualify for a loan. So this if condition was true. Hence, we are executing this nested if-else statement. Then the second condition was true. Years on the job was 4, greater or equal to 2. That returns true. Hence, we execute this statement. After we executed one of the options, we don't look at the else. Like if we did if statement, we don't look at the else here. We skip it. And we don't even check the else statement. We don't even execute else statement here because this one was true. So this is an if-else statement with an inside if-else statement. Before we are done, I'm going to question the usefulness of this line where it is currently. Let me run it again. My salary is 25,000. How long on the job? 5 years. You must earn at least 30,000 per year to qualify. So everything works right. The result is correct. However, let's think how it worked. My salary was 25,000. It was entered in the first line. Then I entered the years on the job. 25,000 bigger or equal to 30,000 is false. Hence, this statement did not get to run, and else was executed. So in essence, I defined the variable years on the job and never used it in this scenario. In the previous scenario, of course, I did. So how can we make this code better? Pause, think about that. All right, and of course, the answer to my question is to move the second variable, the second input, inside the if case, if block of statements. If salary is greater or equal to 30,000, then it makes sense to ask for years on the job, because otherwise you are immediately rejected and there is no reason to even know how many years on the job. So hopefully that makes sense.